Hi students, myself Kale SL, रयत शिक्षण संस्था RBNB College रामपुर. 12th Science Mathematics Part 2. Topic is Definite Integration, Exercise 4.2. In the previous video lecture, we have started this topic Definite Integration. And in exercise 4.2, there are 3 questions. Question first, question second and question third. Each question contains 15 problems. So we have started here question first in the previous lecture and completed 6 problems. Today we take next problem, problem number 7 and remaining problems. So let us see here problem number 7. Question first, evaluate problem number 7, integration from 0 to pi by 4 sin of 4x sin of 3x dx. This question number first and question number second, just it is the revision of previous chapter indefinite integration. Only we have to use here how to use the fundamental theorem of integral calculus, that is, if integration of f of x dx, integration of f of x dx is equal to g of x plus c, and we have to use here lower limit and upper limit. Then we take here integration from a to b, f of x dx is equal to this solution as it is g of x plus c, and take here square bracket like this and write here lower limit a and on the top side upper limit b. And now take here g of, in place of x we put upper limit, that is g of b plus c, and then take minus sign and g of, in place of x now put lower limit a, g of a plus c, and now open this bracket. So we get here g of b plus c minus g of a and minus g of minus c. This minus c and plus c get cancelled, so it is equal to g of b minus g of a. We have seen this fundamental theorem of integral calculus. So we have to use only lower limit and upper limit in question number first and question number second, because we have seen all the problems in the next previous chapter indefinite integration. So now let us see here problem number 7, integration from 0 to pi by 4 sin of 4x sin 3x dx. Let us call this as I. Let I is equal to integration 0 to pi by 4 sin of 4x sin 3x dx. This is the trigonometric functions. Now in the trigonometric functions, firstly we have to use here formulas, and then if we need substitution method, use the substitution method. Now we adjust here 2. So this is equal to integration 0 to pi by 4. Here we take 2 times sin of 4x into sin of 3x dx. Why we take here 2? We know the formula of 2 times sin A sin B. So we adjust this 2. So cancel this 2. So 1/2. So 1/2 into 2. 2 get cancelled. And now use the formula 2 times sin A sin B. Since we know 2 times sin A sin B, it is equal to cos of A minus B minus cos of A plus B. We have seen this formula in the 11th standard. There are 4 formulas: 2 times sin A cos B, 2 times cos A sin B, 2 times cos A cos B, and 2 times sin A sin B. So this is the formula. So I is equal to this required integral, I becomes this 1/2 as it is, integration from 0 to pi by 4. And it is now cos of A minus B minus cos of A plus B. A we put 4x and B as 3x. So cos of A means here 4x minus B means 3x minus cos of A 4x plus B 3x dx. So this required integral I becomes, I is equal to I is equal to integration of this 1/2. So 1/2 as it is, this 1/2 integration 0 to pi by 4, integration 0 to pi by 4, and cos of 4x minus 3x, 4 minus 3 1, so cos x. So cos of x minus cos of 4x plus 3x, 4 plus 3 7, so cos of 7x. cos of 7x dx. We separate the integration. So this is equal to I is equal to this 1/2 as it is, integration 0 to pi by 4 this cos x dx minus this 1/2 into integration 0 to pi by 4 cos of 7x dx. And we know that integration of cos x is sin x, integration of sin x is cos x. So I is equal to this 1/2 as it is, integration of cos x is sin x. Answer start with C, answer start with S. So here it is plus. So 0 to pi by 4. This minus 1/2 as it is. Here also integration of cos x is sin 7x divided by derivative of 7x as 7, and it is from 0 to pi by 4. Now in place of x we put upper limit, minus in place of x put lower limit, and so it is equal to this 1/2 as it is, sin of x is pi by 4, so sin of pi by 4 minus sin of x is now 0, lower limit is 0. This minus 1/2 into this 7, that is 1 upon 2 7s are 14, and now here sin of 7x 0 to pi by 4, so we put here sin of 7 into x, x is pi by 4, so 7 pi by 4, 7 pi by 4 minus sin of 7 into x is 0, 7 into 0 that is 0, and so we get here 1/2 as it is. Sin of pi by 4 we know, sin of pi by 4 45 degree, it is 1 upon root 2, 1 upon root 2 minus sin of 0 is 0. Here minus 1 upon 14 as it is, and sin of this 7 pi by 4, we adjust this 7 pi by 4 like this. Sin of 7 pi by 4, we write this 7 pi by 4 is equal to 4 pi plus 3 pi upon 4, and then take separate division, that is 4 pi upon 4 it is pi plus 3 pi by upon 4, 3 pi by 4. So we write this 7 pi by 4 as pi plus 3 pi by 4, pi plus 3 pi by 4, and now here minus sin of 0 is 0. So here it is equal to 1 upon 2 into 1 upon root 2, it becomes 1 upon 2 root 2 minus this 1 upon 2 into 0, that is 0. Now here minus this 1 upon 14 and sin of 180 plus theta. Sin of here pi means 180, 180 plus theta, it lies in which quadrant? Third quadrant, and in third quadrant sign is negative. So that negative sign and this negative sign become plus. And sin of 180 plus theta, that is equal to sin theta, because here pi means on the x-axis. On the x-axis we take sin as sin, cos as cos, etc. Only we have to consider the sign in which quadrant that angle lies. So here it lies in the third quadrant, so it is negative. So negative and this negative become plus, and now it is sin of 3 pi by 4. And minus here, minus plus 1 upon 14 into 0, that is equal to 0. There is no need to write here 0. Now here we have to find what is sin of 3 pi by 4. So this required integral I becomes I is equal to this 1 upon 2 root 2 as it is, 1 upon 2 root 2, then plus 1 upon 14 as it is. And now here sin of 3 pi by 4, sin of, now again here 3 pi by 4, we write this as 4 pi minus pi, 4 pi minus pi, that is 3 pi divided by 4, and now take the separate division, 4 pi upon 4 it is pi minus this pi by 4. So we replace this 3 pi by 4 by pi minus pi by 4, pi minus pi by 4. And now here, so I is equal to this required integral becomes 1 upon 2 root 2 plus 1 upon 14 as it is. Sin of 180 minus theta, it lies in which quadrant? 180 minus theta, it is in the second quadrant, and in the second quadrant sign is positive. And therefore here it is sin of pi by 4. sine of pi by 4. 180 minus theta. Angle lies on the horizontal axis, x-axis. So we take sine as a sine. On the y-axis, if it is here pi by 2, 3 pi by 2, then we change sine as cos, cos as sine, tan as cot, cot as tan, etc. But here pi is on the x-axis, so the solution of sine is sine. And theta is here pi by 4. And now here sine of pi by 4, sine of 45 degree, it is 1 upon root 2. So it is equal to 1 upon 2 root 2 plus 1 upon 14. And this sine of pi by 4 is 1 upon root 2. So it is equal to 1 upon 2 root 2 plus 1 into 1, 1 upon 14 root 2. Here root 2, here root 2, here 14. Here we have to make this as a 14 by multiplying 7. 7 2s are 14. So 7 into 1, 7. 7 plus 1, that is 8. So 8 upon 14 root 2. And here 2 4s are 8 and 2 7s are 14. We divide by 2 to this 8 and 14. So we get 4 upon 7 into root 2. This is the required solution. So highlight this solution, take the screenshot and write in your notebook. So now we see here eighth problem. Integration of under root of 1 plus sine of 2x dx and integration from 0 to pi by 4. 0 to pi by 4. We call this as I. Let I is equal to integration from 0 to pi by 4 under root of 1 plus sine of 2x dx. Now here also we use the formula of sine of 2x. We know it is 2 times sine x cos x. So this is equal to integration from 0 to pi by 4 under root of here plus sine of 2x is 2 times sine x cos x. Now we write here sine of 2x as 2 times sine x cos x, and we put the value of 1 in terms of sine x and cos x. We know the first fundamental identity, that is sine square theta plus cos square theta is equal to 1. So we put 1 as sine square x plus cos square x. And so it is equal to integration from 0 to pi by 4 under root of, now here it is a square plus twice ab plus b square, so a plus b bracket square. So we write this as sin x plus cos x bracket square dx. Now this square root and square get cancelled to each other and we get, so I is equal to integration from 0 to pi by 4. Square root and square get cancelled to each other, so remains here sin x plus cos x. Sin x plus cos x dx. Now we separate the integration, so it is equal to integration 0 to pi by 4 sin x dx plus integration 0 to pi by 4 cos x dx. And now take the integration, so this is equal to integration of sin x is cos x, but answer start with c, so it is minus, so minus cos x, and take square like this and 0 to pi by 4 plus here integration of cos x is sin x. Answer does not start with c, so it is positive, so 0 to pi by 4 here also I. So it is equal to, now in place of x upper value minus in place of x lower value, that is minus in the bracket cos of x is pi by 4 minus cos of x is 0, cos of 0 plus here sin of x is here pi by 4, sin of pi by 4 minus sin of 0. So it is equal to minus cos of pi by 4, cos of 45 degree, it is equal to 1 upon root 2. So 1 upon root 2 minus cos of 0 is 1, we know it is, plus sin of pi by 4, again sin of 45 degree, it is also 1 upon root 2. So 1 upon root 2 minus sin of 0, it is 0. And so we get here minus 1 upon root 2 multiplied by minus sign, and minus minus plus 1, here plus 1 upon root 2, and this 0 we can't write here. This minus 1 upon root 2 and plus 1 upon root 2 get cancelled to each other, and so it is equal to 1. So the answer is here 1. I is equal to 1. This is the solution. So take the screenshot. Now, ninth problem. Integration of 0 to pi by 4. 0 to pi by 4 sine raised to 4x dx. Now, let us assume this as I. So, I is equal to integration 0 to pi by 4 sine raised to 4x dx. So it is equal to integration from 0 to pi by 4 sine square x to the square. We write this 4 as 2 to the power 2 using the rule of indices, and dx as it is. And now put the value of sine square x. Sine square x is, first value is sine square x is 1 minus cos square x. And sine square x is 1 minus cos of 2x upon 2. Which value we put here? We put this value, sine square x is equal to 1 minus cos of 2x upon 2. So it is equal to integration from 0 to pi by 4, 1 minus cos of 2x upon 2 bracket square dx. Now take the square. So this is equal to integration from 0 to pi by 4. Here it is 1 minus cos of 2x bracket square upon 2 square is 4. Numerator upon denominator square is equal to numerator square upon denominator square. Now we expand the numerator. So I is equal to integration from 0 to pi by 4. Now use the formula a minus b bracket square, that is a square minus twice ab plus b square. A square, that is 1 square, is 1 minus 2 into a into b, 2 into 1 into cos of 2x, that is 2 cos of 2x, plus b square means cos square 2x, cos square 2x divided by 4 and dx. And now again we have to use here cos square 2x. Just we have seen here sine square x is equal to 1 minus cos of 2x upon 2. Similarly, cos square x is equal to 1 plus cos of 2x upon 2. And all these two formulas we obtain from the formula of cos of 2x. Cos of 2x, there are 4 formulas. Cos of 2x is equal to, first formula is cos square x minus sine square x. Second formula is 1 minus 2 times sine square x. Third formula is 2 times cos square x minus 1. Fourth formula is 1 minus tan square x upon 1 plus tan square x. So now here we use this and this formula to obtain the value of cos square x and sine square x. Then we get here sine square x as 1 minus cos of 2x upon 2 and cos square x as 1 plus cos of 2x upon 2. And so we get here this I becomes I is equal to integration 0 to pi by 4, this 1 as it is minus cos of 2x as it is here 2, plus now we put cos square 2x as 1 plus cos of 4x, because if here x, then here it's a double angle, x 2x, so here 2x, so we get angle as a 4x. So we get here 1 plus cos of 4x upon 2 and whole divided by 4 dx. So I is equal to integration from 0 to pi by 4. Now we separate, we divide by 4 separately to numerator. So it is 1 upon 4 minus 2 times cos of 2x upon 4 and plus here 1 plus cos of 4x upon 4 into 2, this is 8 dx. 4 into 2, that becomes 8. Here 1 upon 4 minus 2 cos of 2x upon 4 plus 1 plus cos of 4x upon this denominator into this denominator, that is 4 2s are 8. And now here 2 1s are 2, 2 2s are 4. And now take the separate integration. So it is equal to this 1 upon 4 constant. So 1 upon 4 integration 0 to pi by 4 dx. 1 dx means dx minus here 1/2 constant. This 1 hand divided by 2. So 1/2 integration of cos of 2x dx, integration from 0 to pi by 4, plus here we divide 1 by 8 separately and cos of 4x by 8 separately and take the separate integration. So integration this 1 upon 8 constant, 1 dx means dx, and plus 1 upon 8 into integration cos of 4x dx, and integration from 0 to pi by 4, 0 to pi by 4. And now take here integration. So it is equal to this 1 upon 4 as it is, integration of 1 dx means x, it is from 0 to pi by 4, minus here 1/2 as it is, integration of cos, that is sine. So sine of x, but in place of x there is 2x, so divide by its derivative, derivative of 2x is 2, so divide by 2, and it is integration 0 to pi by 4, plus here 1 upon 8 as it is, integration of 1 dx x, and it is from 0 to pi by 4, plus here this 1 upon 8 as it is, integration cos of 4x, that is sine of 4x, divided by derivative of 4x, that is 4, and it is from 0 to pi by 4. Now we put the upper value and lower value in place of x. So required integral I becomes I is equal to I is equal to 1 upon 4 and x from 0 to pi by 4. In place of x we put pi by 4. So pi by 4 minus 0. Pi by 4 minus 0. Then here this 1 upon 2 and this 1 upon 2, that becomes 1 by 4. So here minus 1 by 4 in the bracket. 1 upon 2 into 2, 4. Sine of 2 and x is here pi by 4. So 2 into pi by 4. So it becomes sine of pi by 2. So it is sine of pi by 2. Again see, sine of 2x. So 2 into x is pi by 4. 2 into pi by 4. 2 2s are 4. So it is pi by 2. Minus here, now put x as 0. So sine of 2 into 0, it becomes 0. So sine of 0. Sine of 0. Then here plus 1 upon 8. Plus here 1 upon 8 in the bracket. Now x is pi by 4 minus x is 0. So pi by 4 minus 0. Pi by 4 minus 0. Now plus 1 upon 8. Here we write plus 1 upon 8 in the bracket. Sine of 4 and x is pi by 4. So 4 into pi by 4. 4 get cancelled, pi. And this 8 4s are 32. Here we write 8 4s are 32. And now here sine of pi minus sine of, now we put x as 0. 4 into 0, that is sine 0. Sine of 0. So we get here I is equal to this 1 upon 4 into pi by 4. 1 into pi, that is pi, upon 4 4s are 16. Minus this 0, there is no need to write here. Now minus 1 upon 4 into sine of pi by 2, or write here 0, suppose here 0, minus 1 upon 4 and sine of pi by 2 is here 1, minus 1 upon 4, minus minus become plus 1 upon 4 this, and sine of 0 is 0, plus here this 1 upon 4 8 into pi by 4, that is pi upon 8 4s are 32, minus 1 upon 8 into 0, that is 0, plus here 1 upon 32 sine of pi. Sine of pi and sine of 0 same. that is here 0, so 0 minus 0. And now we get here I is equal to this pi by 16, and here minus 1 upon 4, 1 upon 4 into 1 upon 4, here it becomes 0, and here plus pi upon 32, here 0, it is 0. So we get here I is equal to this pi upon 16, this pi upon 16 plus this pi upon 32 minus this 1 upon 4 as it is. So I is equal to, we get 16 to the 32. So 2 pi plus pi, that is 3 pi upon 32. Here 32, we have to make this as 32, so multiply by 2. So 2 into 16, that is 32. So we multiply numerator by 2, 2 into pi, that is 2 pi. Denominator now 32. So 2 pi plus pi, 3 pi divided by 32 minus 1 upon 4 as it is. Again we make denominator as 32. So this is I is equal to 3 pi minus, we have to multiply by 8, 8 4 is 32, so 8 into 1 8, so minus 8 divided by 32. This is the final solution. Take the screenshot. So in this way we have completed here 9th problem. Now 10th problem, integration minus 4 to 2, 1 upon x square plus 4x plus 13, x square plus 4x plus 13 dx. Now we have to identify the type which we learned in the previous chapter. So this problem depends on integration of 1 upon ax square plus bx plus c dx. To solve such type of problem, we make the coefficient of x square as 1. Here the coefficient of x square is 1. Then we complete the square and we use standard formula, integration of 1 upon x square plus a square dx, or 1 upon x square minus a square dx, or 1 upon a square minus x square dx. So firstly we call this as I. So let I is equal to integration from minus 4 to 2, 1 upon x square plus 4x plus 13 dx. So I is equal to integration from minus 4 to 2, 1 upon, here we have to complete the square because coefficient of x square is 1. Now complete the square. We have to add 1/2 into coefficient of x bracket square. So this x square plus 4x as it is, here plus 13 as it is, here we have to add a third term, that is 1/2 into coefficient of x is 4 bracket square. So 2 1s are 2, 2 2s are 4, 1 into 2, 2 square, that is 4. So we have to add here 4. So plus 4, here plus 4, and cancel this 4, so it is minus 4, and write here dx. So I is equal to integration from minus 4 to 2, 1 upon, now this x square plus 4x plus 4, it is the complete square of square root of x square is x, middle sign is plus, so here plus, and square root of 4 is 2 bracket square. Now plus 13 and minus 4, 13 minus 4, that is plus 9, and 9 we write it as 3 square dx. And now we use here standard formula, integration of 1 upon x square plus a square. Now remember the formula, integration of 1 upon x square plus a square, that is equal to 1 upon a into tan inverse of x upon a. So I is equal to, now we take directly integration. Here integration minus 4 to 2, 1 upon, this is suppose x square plus a square, that is equal to 1 upon a is here 3, so 1 upon 3 into tan inverse of x means this bracket, that is x plus 2, x plus 2 upon 3, and integration from minus 4 to 2, So here minus 4 and upper limit is 2. Which formula we use here? Since integration of 1 upon x square plus a square dx, it is equal to 1 upon a into tan inverse of x upon a plus constant of integration. So I is equal to 1 upon 3. Now tan inverse of, in place of x we put 2 and then minus 4. So tan inverse of x is here 2. So 2 plus 2, that is 4 upon 3. Minus tan inverse of, in place of x minus 4, minus 4 plus 2, that is minus 2 upon 3. And so we get here I is equal to 1 upon 3 into tan inverse of 4 upon 3, and we write here plus minus, this is minus, then tan inverse of minus theta is minus tan inverse of theta, so minus minus become plus. So tan inverse of 2 upon 3, here we use tan inverse of minus theta is equal to minus tan inverse of theta. And so this is the final solution. Highlight this solution and take the screenshot. So in this way we have completed here 10th problem. Now next problem, 11th problem, integration 0 to 4. Integration 0 to 4, 1 upon under root of 4x minus x square, 4x minus x square dx. Here also we have to identify the type of the integration, that is integration of 1 upon under root of ax square plus bx plus c, but here x square is negative. So firstly call this as I, so I is equal to integration 0 to 4, 1 upon under root of 4x minus x square dx. And when x square is negative, we use here a trick that integration 0 to 4, 1 upon under root of, we take minus sign common in the bracket, this become plus and this minus, minus 4x and dx. And now complete the square. So this is equal to integration 0 to 4, 1 upon under root of this minus sign as it is in the bracket, this x square minus 4x, and now here we have to add 1/2 into coefficient of x, that is 1/2 into minus 4, 2 2s are 4, so it is minus 2, 1 into minus 2, minus 2, it's a square, plus 4, so we have to add here plus 4, so this is plus 4 and minus 4, and we complete bracket dx. So this required integral I becomes I is equal to integration from 0 to 4, 0 to 4, 1 upon under root of this minus sign as it is in the bracket, x square minus 4x plus 4, it is the complete square of x, square root of x square is x, middle sign is minus, so minus, and square root of 4 is 2, so x minus 2 bracket square, and this minus 4 with this minus sign become plus 4, so plus 4 and dx. So I is equal to integration 0 to 4, 0 to 4, 1 upon under root of, we write this 4 firstly, that is 4, 4 means it is 2 square, so we write this as a 2 square, minus this x minus 2 bracket square dx. And now use the standard formula. Which is the standard formula? Integration of 1 upon under root of a square, this is a square, minus x square dx. It is equal to sine inverse of x upon a plus constant of integration. And so I is equal to integration 0 to 4, use formula sine inverse of x upon a. So here there is no need to write this, directly we use the formula sine inverse of x, in place of x here it is x minus 2 divided by a is here 2, so divided by 2, and integration from 0 to 4. Get it? Sine inverse of x upon a. X is here x minus 2. If we take the derivative of x minus 2, it is 1. So there is no need to divide by 1. And divided by a. A is here 2. And integration from 0 to 4. Now in place of x we put upper limit, minus in place of x put lower limit. So I is equal to sine inverse of 4 minus 2. 4 minus 2, that is 2. So 2 upon 2, it is 1. Minus sine inverse of 0. So 0 minus 2. So minus 2 upon 2, that is minus 1. And now we get here I is equal to sine inverse of 1 as it is. And this sine inverse of minus theta is minus sine inverse of theta. And this, so minus minus become plus. So it is sine inverse of 1. Here we use, since sine inverse of minus theta is equal to minus sine inverse of theta. We know this formula. And so I is equal to, this I is equal to, this sine inverse 1 plus sine inverse 1, 2 times sine inverse 1. 2 times sine inverse of 1. So 1 is the value. 1 is the value for which angle for sine? That is sine of pi by 2. Sine of pi by 2 is 1. So I is equal to, this is 2 as it is, sine inverse of 1 is pi by 2. This 2 and 2 get cancelled. So I is equal to pi. So this is the final solution. Highlight this solution, take the screenshot. So in this way we have completed here 11th problem. Now we will see 12th problem. 12th, integration 1 upon under root of 3 plus 2x minus x square plus 2x minus x square dx, and integration from 0 to 1. Now this problem we solve using the 11th problem. Here also standard form is 1 upon under root of ax square plus bx plus c. Make the coefficient of x square as 1. Here coefficient of x square is 1. But only here x square is negative. So use the same procedure which we learn here in the 11th problem. Get it? Here call this as I. Then I is equal to integration from 0 to 1. 1 upon under root of here 3 as it is. Now take here minus sign common, then x square, this minus 2x dx, and complete the square and use the same formula, integration of 1 upon under root of a square minus x square dx, that is equal to sine inverse of x upon a plus constant of integration. It is homework to you, solve yourself. Now here 13th problem. Integration 0 to pi by 2. 13th problem, integration 0 to pi by 2. There are 3 problems of this type, that is integration by parts. Integration 0 to pi by 2, x sin x dx. X sin x dx. And here 14th and 15th problem are of the same type. Here 14th problem, integration 0 to 1, integration 0 to 1, x into tan inverse x dx. And 15th problem here, integration 0 to infinity, x into e to the power minus x dx. So these 3 problems depends on integration by parts. I solve here 13th problem, and 14th and 15th problem is homework to you. Now see, let I is equal to integration 0 to pi by 2 x into sin x dx. Now here integrand, this is the integrand, it is the product of 2 functions. These functions are different functions. One is algebraic and another one is trigonometric function. So here we use the Liate rule, L-I-A-T-E, Liate rule. Here x is algebraic, so here x is algebraic, and sin x is trigonometric. Here it is sin x is trigonometric. So a appears firstly, so x is the first function, means u, and t trigonometric function is v, and then use here integration by uv rule. So integrating by parts, so it is equal to firstly x u into integration of v sin x dx minus integration of d by dx of u into again integration of v dx, that is integration of sin x dx, and again take here dx and integration from 0 to pi by 2. Get it? So integration by parts is u into integration of v dx minus integration of d by dx of u into integration of v dx. So it is equal to this x as it is. Integration of sin x, we know it is cos x, so cos x. But answer start with c, so take here minus sign. So here minus sign, and it is from 0 to pi by 2. It is from 0 to pi by 2. Minus here integration 0 to pi by 2. Derivative of x is 1, and integration of sin x is again minus cos x, and this dx as it is. And so it is equal to this minus in the bracket this x into cos x 0 to pi by 2 minus, and this minus become plus. And now here 1 into cos x, 1 into cos x is cos x, so integration of cos x is sin x, or we may write here integration of cos x from 0 to pi by 2 dx, and then take integration of cos x as a sin x, and it is from 0 to pi by 2. And now put upper value minus lower value in place of x. So we get here I is equal to minus sign as it is in the bracket. In place of x we put pi by 2, so pi by 2 into cos of pi by 2, pi by 2 into cos of pi by 2, minus in place of x we put 0, 0 into cos of 0, that is 0, 0 into something, that is equal to 0. Now here plus sin x from pi by 2 to 0. So we put x as a pi by 2 and then x as a 0. So sin of plus here sin of in place of x pi by 2 minus sin of in place of x 0. So here it is equal to cos of pi by 2, we know cos of 90 is 0. So minus in the bracket pi by 2 into 0 minus 0 plus here sin of pi by 2, we know sin of pi by 2, sin of 90 is 1 minus sin of 0 is 0. So this is all 0, so there is no need to write here 0, and here 1 minus 0, so it is 1. So I is equal to 1. We get here I as 1. This is the final solution. So in this way we have completed here 13th problem. Use the same method and solve here 14th and 15th problem. In 14th problem, see integration from 0 to 1 x into tan inverse of x. Here use LIATE rule. L logarithmic I inverse. So tan inverse x is u and x is v. Here in 15th problem, integration 0 to infinity x into e to the power minus x dx. Here e to the minus x is exponential function, so it is v, and x is u, that is the algebraic function. And now use here integration by parts method and solve 14th and 15th problem. So in this way we have completed here 15th problem in question number 1st. In the next video lecture we will see question number 2nd and then question number 3rd. Today we stop here. Thank you.